Okay, welcome everybody for our next talk by Scott McAllister. Built-in testing in Go is more than just Passable. Please welcome Scott McAllister.
All right, before I start, I come from Seattle, Washington, so it's a little bit farther from here than other things. And so I need you all to help me out. I need to prove to my boss that I actually gave a talk and people actually came. So if you all just real quick, wave for me. Yeah, thank you so much. It's funny, I use these pictures every time because they love them. They like to see that I'm actually here and that I actually gave a talk. But we're not here to talk about me. We're here to talk about testing in Go. And I'm going to take you on my journey that I went through to learn about testing in Go. And every good journey starts with a good story. So a few years ago, I joined this company called PagerDuty, and as a new employee, I wanted to impress. I wanted to provide value straight up, and you know that new feeling in a new job, and you just want to find that thing that makes people happy, makes your customers happy, makes your boss happy, all those types of things. And so I was talking with another developer advocate, and that's what I am, sorry. I'm a developer advocate at PagerDuty. And as a developer advocate, what we do is we talk to people about our developer offerings, so our APIs and our different tools connected to our APIs. And I was talking with this developer advocate, and we were in the lunchroom there, and one of the things he asked about was, or that I asked about, I was saying, what about our SDKs, our client libraries? And he said, oh, we have this Go library. It's great. It's really popular. People really like it. The problem is, whenever there's a PR, it takes a really long time to review those PRs because we don't have any testing built in. Right. So I wrote that down in my notebook, and I made that mental note. Okay, that's something I can do. That's a quick win maybe that I could get with my company. But as things go, right, priorities change, different tasks come in, and that bumped down on my priority list. And so a few years later, I had some time to look at this Go library. Before I started looking at the Go library, I was introduced to something else that we had at PagerDuty that no one inside the company was working on. Our community was working on our Terraform provider. And if you know anything about the Terraform providers, they're all written in Go. So I learned a lot about Go, getting involved with the Terraform provider, and a lot about the testing, because there was testing already written into that provider. And those tests actually included libraries from outside, the built-in Go language libraries. And so that's what I thought, that sounds normal. I'll use that. I'll use this type of testing when I want to add testing to this SDK, so the Go PagerDuty SDK. And as it happens most of the time, right, around December. December is when we get a little bit more time to do things. We have around the holidays, and so around the holidays, I dug into this Go PagerDuty library, and I added tests. And I used the patterns I saw in the Terraform provider. And I was so proud of this thing, I opened the pull request, and I thought, well, for sure, anyone who looks at this pull request, they're going to see this code, and it's obviously going to be good. And it's just going to go sailing straight through. And I started talking to folks inside the company, trying to find someone to review my pull request. But before I could find that someone inside the company to review, the community found it. And there was a member of the community that gave me some feedback. It was good feedback, but it's feedback that I've not forgotten. And this member of the community is a really smart member of the Go community. You might have seen him on the Go for Slacks, as you'll see his name when it pops up on the screen here. And he was very blunt, but also very helpful. The first bit of feedback was this. I added tests to all the endpoints on our API, all the endpoints in the SDK that our API supports, and then all the actions. It's a lot of code. So that first bit of feedback he gave me was like, hey, dude, this is a really big pull request. I'd love to review it, but there's a lot of code here, and I don't have time to look at this thing. So that was one thing I learned. I could have broken my pull request up into little bits. But what we're talking about today is the next bit of feedback that he gave me. He wanted me to use the standard libraries for testing. And I thought, well, why? I came from other programming languages for when you need to write tests in other languages, you had test suites. If you were in JavaScript, you'd use Mocha or Jest. If you're using Python, you'd be using PyTest, or I think it's called Robot, that one in the left-hand corner. If you're in Java, you're probably using JUnit or JBehave. These are things that are external to those libraries, so I thought, why not? But this is what got me on my journey to kind of see what I needed to learn, what happened in the Go world as far as testing goes. Because with Go, as many of you know, it was built by Google for our benefit as developers, to be more productive, to be faster, to get things done quicker so they could write better and bigger things. There's a lot of promises that Google gave us when they built the Go programming languages and the Go team, not just at Google. But the main thing, built-in testing, as testing built into the library. And so that's when I started discovering what I could do with the library that's already built inside of the language. To level set, let's just make sure that we all understand. Testing. Testing is code. It's not application code. That's different, but it is code. We learned yesterday from the closing keynote, your tests are programming. It is an application in of itself. But your tests evaluate. They make sure that your application code is going to behave exactly as you expect it, that you have no side effects. Okay, so you want to validate and evaluate your code to make sure it does what you're expecting. And that leads to another point. I was actually sharing this idea with a coworker of mine who also writes Go. And I kind of went through my talk with him, and I talked about how, testing what I introduced testing and things like that. And he laughs, and then he says, you know what I learned when I first started writing tests in Go? That I needed to write application code that was testable. He had big functions that wrapped around lots of other functions, and you couldn't really test that big wrapper function if it has lots of things on the inside. So write your code so that it can at least be single responsibility, right? And try to decouple things as much as possible. That way, when you run tests, you can test those little pieces as we talk about. Adler gave this great quote recently. What I like about it is it talks about how it encourages clear design and it boosts our productivity. Again, all goes back to that productivity. A lot of times when we think of testing, when I've thought of testing as an engineer, you think about writing tests, and a lot of times you actually throw them in at the end to say, oh, right, we need code coverage. Boom, let's slap these tests in. But really, we want to make it so that we can make it a productive process. As we're going through our application, as we're adding more features, we have these automated tests for us so that we can be sure of our code as it builds, not just one big project that we decide to throw tests in at the end. So a couple of different types of testing, at least that we'll talk about today. First is unit testing. It's when you're breaking your application code down to the smallest bits possible that you can isolate. Now, by isolating, I mean really isolating. Unit tests don't even reach out to other APIs. They don't reach out to other systems, to databases. You're just testing that unit. You're testing that function. And then, as your programs are, your units are going to be interacting with each other. So you're going to want to write tests that test that workflow, that chain of events. When you have lots of different units that are going to finish a certain process, you want to make sure that that whole process works too. So not just the little individual bits, but all the bits in one big line. So that's called integration testing. So now that we have a level set of what testing is in general, kind of the background of where I came from, let's talk a little bit about how Go handles testing. Now, this first idea is the fact that most Go test files sit inside of the application, at least in the projects that I've worked on. I've worked on several open source projects where I've seen this type of behavior. I've also read and heard from other folks inside of the Go community that it's good to separate your tests out. Entirely up to you. But from what I've seen, it's listed all in the same spot. And here's the nice thing about it, that I've found at least. To have a file that Go understands as a test file, you put the underscore test in the file name. When you have that underscore test there, those files are not compiled when you compile an application. When you compile your Go applications to run and to distribute, these files won't be compiled. And whenever you run the go test command, only those files will be run. So that's nice, and plus visually it's nice. In our case, I'm writing an SDK. That SDK supports lots of resources that are different objects that are available in our API. So I can see that, okay, I have an ability endpoint, I have an add-on endpoint, I have an analytics endpoint, but then I know it's tested because of the test file is right next to it. And we can see that they're listed in your file structure. And then inside the tests, that test file, you're going to have test functions. And each of those functions need to have a few different requirements when you're writing those. The first is that it needs to start with the name test, and then it's a good idea to have the action of what you're testing. Obviously, hello empty isn't helpful, except for the fact that as a demo, and it makes you maybe giggle a little bit. And then the second thing is you have this argument of testing.t. You're passing in this pointer that's required so that when the tests run, you have access to lots of different utility functions. We'll look at a few today. My purpose today, I hope, is that I'll introduce you to a few key concepts, introduce you to a few key ideas, and then you can take what I've shared with you and then run with it and learn about all the vast possibilities inside of the testing library. So you pass in that testing.t, and then that allows you to have access to those different utility functions. As I mentioned, some of those functions make a lot of sense, error functions, skip functions. Keep an eye on that run function, because when I first learned about the t.run, I thought it did something different than it does. Just put that in your mind. We'll come back to it in a second. So a test. What does a test look like? What are you doing when you're running a test? You're going to have some expected or some inputs that you're going to throw at your function. And then you have some expected outputs. In this case, I know that if I pass a 111 to this particular function, I'm going to get a 333 back. That's what I expect. I'm going to make sure that my test does that. Then my test actually does the magic. It hits the function, runs that unit, right? And then gets us a value back that you're going to compare. You're going to compare that or assert that the value of expected is the same as the value that you got. If it's not, you got problems. Then you can look at that failed test and figure out why it's failed and make sure that you can fix your code or your test. A lot of times your tests are just busted. But make sure that your tests are good and your application code is good before you continue on with your application and your development. And then it's easy as running go test. That's the command that you'll run to run all of your tests. Again, lots of different arguments that you can pass in with test. But let's look at some code now, because that's more fun than looking at slides. So what I have here, I have a real simple application. My plan is to show you a real simple application, show you some very simple tests that don't have a lot of distractions, a lot of different things happening, so you can get the concepts of what the tests are doing and how we're doing the tests. And then I'll actually show you the code that we're using in our SDK. That way you can see, okay, in real life, this is how this test would work. This is how I would run unit tests, or how we're going to be doing a few other concepts. So in our case right now, I have a real simple application that's a calculator. Command line calculator. Its main engine here is this math file that has an add, subtract, multiply, divide function. We're doing an MVP. We're going to have two inputs here, just two, for each of these operations. There's also a CLI section, but we're not going to test that right now because, to be honest, we're not real sure it works and we don't care yet. We want to make sure that the math functionality actually works. So my file structure is just like what I was explaining before. You see here on the left-hand side, we have our main, we have our math, but then I have my math test file sitting right in the same directory. So my math.test, let's look at this test we have. So we have two arguments that are being passed into add. So I have a first, I have a second, and then what I expect, so that's my want. And then I have a got, which is running my add function. And then I'm going to see, okay, if got isn't equal to want, I'm going to fail this test. Make sure that that message is passed up. So we're referencing fatal.f, which is off that T object. And then we're giving it a little bit better of a message rather than kaboom, right? So we're letting it know that, okay, this is what happened. We had an input of this and this. It should have been this. It was actually this. So if I run this test now, we're good there, okay? So I'll just do a real quick go test here. Yippity-yay, it passed. However, is that very helpful? Right? Not a lot of information coming back here. So one of the arguments that I recommend that you just get in a habit of running, you want to do a -v. Give it a verbose. Make sure that when you run it, you can actually see, okay, this test ran, this test passed. And then maybe on your first test, you want to make sure that the failing part of your test also works as expected. And what did we hear yesterday? How somebody was writing tests for their tests? I mean, you want to make sure your tests are working. And so if I came in here and said, well, I want to make sure this is actually doing what it says it's doing, so I'll make sure my want is busted. And then I get this great message. And the message tells me it's very informative because we wrote it, right? So we have what our input plus our other input should have been this, it was this, and that'll help us go in and debug our test. But like most good tests, you want to be able to test more than just your function once or in one way. And so I'm going to try to test this add function yet one more time. And because typing in front of other people, whether it's 100 people at GoLab or your coworker who's sitting over your shoulder, is terrifying, and we always mistype things, at least I do, I have my tests written out here in my comments here. So we'll look at this test. We wrote another 10 lines of code to get another test that looks really, really similar to our last test. Only difference is I have that first and second and want values. Those are different, but everything else is the same. Makes sense. I mean, tests sometimes get repeated as you're writing them. But in programming, we hear a lot about the dry principles, right? To not repeat yourself. But in this case, you feel like you have to because, well, I want to test that add function again because I want to throw negative numbers at it. I want to see what happens if I throw a negative number at this thing. And so I have my test. I'm going to run it. Okay, good. My test run. Ooh, that's not awesome. Anyway, we'll clear this for the next one so it doesn't get all busy. And that's great. That's fine, but it's still 30 lines of code doing similar things twice. We also want to test an integration, so let's make sure that our functions not just add by itself, but lots of the functions. If we call them all at once, how would that behave? So I have another test here for an integration. In this case, right here on line 36 at the top, we're going to call the multiply function. Its two arguments are going to be a call to the add function, a call to the subtract function. We're going to mix all those things together, and we should be getting a number close to somewhere around 30,000 or so. If we start off with 100 and 200, and we do that there. We have these. Our first test failed because we broke it, but that integration test also worked, and that's great. The thing that I want to point back out to is the fact that we had to keep writing this code over and over to get these multiple tests. There's something built into that utility, the testing.t object, that allows for something called subtests. T.run is actually a way to run a test inside of a test. Because Go already understands that that test function is a test. But if you run or wrap something inside of t.run, you get to be able to run a test inside of that test. And so with subtests, we can start doing something called table-driven testing, which is a concept that is pretty unique to Go, at least as far as I've understood it. And it happens because we can take a slice of structs, we can define that struct with some expected values. So we have an input and an output, expected output value. And then we can list those values all in a list here. And every time we want to add a new test, we just add a new set of values. And that way, we can expand the number of tests we're doing without writing heaps and heaps and heaps of lines of code. How we get through those, we come back around, we'll loop over them, or range over those tests. Each one of those tests has a name. Each one is wrapped inside of this t.run. That t.run, if you look what's inside of it, it's meat. That's the same as the stuff that we wrote before. We have the got, we'd have the assertion, so we check to see if the expected is not got, and then we have our error message. But again, slides are boring, let's look at real code. We'll pull out of here and come back over to our math.test. And now in this one, I have a function called testAll. I want to step through this a little bit just to kind of explain how things are going. So in that first one, we're defining our struct with these fields. We have a first, remember we have our second, we have our want. Those are all float 64s. And then here's each of our tests. In fact, I won't do that one. And we can write all these tests easily just in a nice little table here. And then I have my for loop. Gives it a name, which is taking in each side of that, each of those tests. Each of those objects just gets a name by taking the first and second values. We put that test name on the t.run. T.run has a callback function, which is essentially our test function. We call add, we do our assertion, and it's all good. We're now testing five different tests, or 5 different scenarios, as I was trying to say, with just a few lines of code rather than 20 lines of code for each of those 5 tests. Coming back out here, we're going to output this, except for it's busted. Let's look at that real quick. 76. That's what happens when you comment everything out and then you don't uncomment everything that should be uncommented. Right, okay, so now we have an output that looks similar to what we had before, but a little more involved. You notice down here, we have this section of indented tests. This lets you know that these tests are subtests. These are ones that are being called by t.run, and so you can have an idea, all right, these are the ones that are kind of in that loop, so I can find them a little bit easier in my code. So we have all these tests here, and we have the outputs, and again, written in those few lines of code. We can even, we have the unit tests that are in the table-driven testing there. I can also take my integration test, make it a subtest of its own inside of that our add all test. We'll run this one, and we see that our integration, it failed. Should have been 40,000, but got 0. So now we can come into here. Right, okay, so this was supposed to be 0. So now we can either look into our application code and understand, was that supposed to be 0? Or we can make sure that our test works and make sure that, okay, that was supposed to be 0. And now everything passes. So leave your messages in a way that are detailed enough to give you and honestly the people after you, because many times you're writing tests for code that other people are going to read. They didn't write that code. We spend more time reading our code than writing it. So make sure that your messages and your code is readable. All right, so that is what it looks like in the simple setup, in the simple environment. What I want to show you now is how we're doing things in our SDK. And so inside the SDK, let me pull out that project. Here we have a test where we're testing some prefixes on some URLs. And so we have that testable, or test table has a struct, what we expect to go in, what we expect to come out. And in this case, we expect these values essentially, in some cases, to stay the same. Some cases, like here, it's going to change a little bit. And then we loop over them and give them those same error messages. We also can do things like testing a couple of different situations with our JSON. If you have a JSON message that's coming in, then you have a different input of this is the JSON body that's coming in, then I want to make sure that this function down here is actually going to be generating a message that's a little more readable. So that's how we're using table-driven testing inside of our SDK. And then I want to show you the unit tests real quick. With the unit tests, because this is an SDK, this is a client library. SDKs are supposed to reach out and hit an API and get information from an API, or send information to an API to post and to put, maybe delete, to get, things like that. So we need to actually mock that type of information. All that is still built in to the Go language. So we have an opportunity to use something called mux, which allows you, it's pulled off the HTTP library inside of the Go language. And we can set up that when a certain endpoint is called, so in this case, there's a type of object called a business service. Its endpoint is /business services. And so when you hit that, if the SDK was supposed to hit that endpoint on the real API, we hope that it would write a response something like, or it will write a response something like this. This is the part where you have to know what your API is doing. So you have to make sure that you get that line right, because that line's got to be the line that's coming back from your API. So the business service with the colon and the curly brackets, all that is what the API will be sending back. And what you're testing and what we're testing in this unit test is that when this comes back, are we setting up that object in a proper way? Are we getting it into the right values, into the business service object, so that it can be passed on to the application using the SDK? Up here you might see a couple of functions, that setup function, that teardown function. This is what sets up that server connection or that mock server connection. That setup function is actually in our client test library. The reason why I want to point to this is because with that setup function, it's actually, let's go here. In fact, let's just skip the spinning around. This is how we set up that server. Real easy, real quick. Not off the side there. And so that we know that, okay, this is the thing I need. I don't really need a real auth token. I just need a value as an auth token. Because you're not hitting the API, you're just generating something that makes the API client library, the SDK, think it's hitting the API. And then also, you have that teardown. So the teardown function is called to close that server when you're done with your test. Now, with these, so there you go. So with those objects and that information from our library and from my little test that I showed you, you can find that code on GitHub. And so that can give you an idea of how to do that code inside of your projects or implement testing inside of your projects. The thought I want to close with has more to do with the idea of testing is more than just a technical thing that you're writing specific inputs and outputs and expected outputs, but it's also a culture shift. Inside of your companies and inside of your organizations, if you're going to have testing and you're going to say that testing is part of accepting pull requests, you want to stick to it. We had a situation recently that on the Terraform provider project that I'm working on, a person opened a pull request and they really needed it pushed through, like now, sort of thing. And they reached out and they said, hey, I opened this pull request. It was a friend of mine, actually. And they said, hey, I really need this particular feature pushed into the Terraform provider. And the test passed, everything's green, it's great. And this person comes from a company that's really smart, especially really smart with Terraform providers. And I thought, they're smart. I could just let this thing through. The test obviously passed. They said it passed. I even pulled the code down. I ran the test myself. They passed. I took one last look at that pull request. They changed the documentation, which is awesome. I mean, who actually changes the documentation when they open a new feature? They changed the application code or the Terraform provider code. But that's all that changed. They didn't change the tests. They didn't add this new feature into the tests, so the tests weren't running this new feature. So I thought, it's just one field on an object, so I'm sure it's still working, but I'll just throw it into the test to make sure. Yeah, totally broke. And come to find out, as I was trying to fix what they did and where it was broken, the feature wasn't quite fully there. It's a good thing that we stuck to making sure the tests pass. So not only make sure that your tests pass, but when you see new features come in, those new features should be tested. They should also include tests inside of your test suite or your test files that you have there. So keep that in mind when you're implementing testing. I'm Scott McAllister. I'm a developer advocate at PagerDuty. We're an incident management software company. And as we like to say at PagerDuty, I wish the rest of you an uneventful rest of your day. Thanks.
If you have any questions, raise your hand.
Hey, thanks for the nice talk. What about mocking? So think about external services like Kafka or databases. What do you suggest we do there?
Yeah, I don't have experience with our project with mocking things like Kafka and databases, but in a similar sense, how we used the HTTP library to mock the MUX. We used MUX to create a server and spin it up and then spin it down for the tests. That's how we did mocking with APIs. I don't know how to do it with databases or with Kafka.
What about when we have tests and we require external dependencies? For example, let's say we use a Docker API, and how we can exclude these from our Go mod? Are you familiar with that, maybe?
So you want to exclude the tests that are hitting like third party?
Let's say we spin up a container with Docker, and we use the API for that, and we use some libraries from Go. Mm-hmm. And when you do Go mod tidy, it downloads this, but it's never used in the project. So
I'm just going to help with that question.
Please, thank you.
So I work on a zero dependency library, and so this is really important for us. And the trick we do is we create like a E2E or other directory, subdirectory. You put a go.mod in that, where your tests are, and then you put in the dependency of your actual project into that go.mod. So let's say whatever your library is called, like foo, you put like your GitHub path to foo there, and then a replace directory to .. So when the test runs in that submodule, it will have more dependencies than the base project. And it will still use the same code as the base project because the replace is going to parent directory. So the only trick is that you can accidentally forget to run those tests because it's actually a different module. So if you do like go test dot slash dot dot dot, it will skip them. So your makefile or your other instructions would have to know to also run the tests in that directory.